In our second project, we're going to take some of the concepts we learned in the first project and apply them into a new type of game. We're going to add the ability for our player to have multiple levels they have to work through, a scoring system along the way, the idea of having lives for each individual player, and multiple other ideas that we want to add to make our games feel much more fully featured and complete. So this, for example, is Brickbusters, and this is a simple kind of breakout or brick breaker kind of game. So we'll play our little game, we can have our paddle, and all we do is bounce our ball, and we're able to control the ball somewhat as we move through the level. And our goal is just to bounce the ball and destroy all the bricks as we go. So very simple and straightforward, but it contains some of the more advanced concepts that are vital to learn to complete your own games. So we've seen it in action. Let's go ahead and start building it for ourselves. So we're going to start out by creating a new project. I've already decided where I'm going to save it. I'm going to give it a project name of Brickbusters, nice and simple, and it's going to be a 2D game. Important always to remember to click 2D to make sure the game is set up in 2D by default. So we're going to go ahead and create this project and open it up in Unity. Now once the project is opened up, we're going to start out by doing some of the same things we did in the previous project and set up some basic defaults for us to work with within our game. So to start out with, we're going to create a bunch of folders here in our assets directory or project folder. So we're going to create a new folder for art. We're going to create a folder for audio. We're going to create a folder for materials, one for prefabs, one for scenes, and finally one for scripts. Nice and simple. One of the first things we want to do is import our art assets into the game. So I'm going to go into our art folder, and then in the resources that are included with the link with the downloads for this series, we're going to drag in these 3 art assets. We're not going to touch the audio folder for now. We're going to import that later, but for now we're going to import these 3 different images we have. So I'm going to drop them into the world here. Okay, so we've got the 3 of them there now. One other thing we want to do is, much like we did with the previous game, we want to use this in a 16:9 ratio because it's the most common ratio used by most people. Because we used it in the previous file, it kind of defaults to that here, but we want to make sure that we select it in our game view so that we know we're working with that view. Make sure we can see everything in our scene view here. Another thing we want to do is again set the background color to be a nice black again. So I'm going to go to my camera, go to the background, make that black, just like that. One thing we want to do now, which is not what we did at the start of the previous project, but for this one, we want to make a few walls around the place like we did before. Now, we've gone through how to do them, so very quickly, I'm just going to drag in the same white sprite that we used last time. I'm going to pop it down here. I'm going to give it a box collider, 2D, as we did before, and then I'm just going to stretch it out like this. I'm actually going to center the positions of it so it's right in the middle, and I'm just going to stretch it out to the edges there like that, and then I'm going to move it up a tiny bit. And what we're actually going to do is leave a bit of space here on top for later on when we add various different bits of text like the score and how many lives our player has and stuff like that. So we want to make sure we leave enough on the top. That's probably a little bit too low, but we can adjust that later when we actually go to add in the text. But for now, we just want to leave a little bit of a gap at the top. We also want to put some walls at the side. So I'm going to rename this one to be a wall first. Then I'm going to duplicate it. I'm going to pull it over to around about here. I'm going to put the scale back to 1 on the x-axis, and then on the y-axis we're going to drag it up like this. I might just move it down a little bit lower. Drag it up some more. And then move it down to there. So what we want to do is make sure that the edges of these 2 boxes line up. So if I zoom in here, now what we could do is just manually try and move it, but you can see as soon as we click off the center axis, we kind of lose that. We could switch to this control and kind of use this and click and drag it around and just try to line it up by eye. But what we can do that's much more handy and much more useful is if we switch back to our move tool, and then in our scene view here, if we hold down, or if we actually click on wall here first, and if we go to our scene view, and if we hold down the V button, it'll lock to the corners of the object. So if we hold V and then click and drag, what it'll actually do then is lock onto the corners of other objects within the world. So what we can do is make it lock onto the very top up here then, and let go, and now you can see the wall gets pushed perfectly into place in the corner just the way we want it to. So we're going to duplicate this wall again to make another one on the opposite side. What we should be able to do is just make this as a positive X value, and it should line up perfectly because the top wall is kind of equally wide either side, so you can see there's no kind of weird shapes going around there either. So there you go, we got our nice simple wall set up. The final thing we want to do is save this scene, so we know that we have a scene that we can permanently be saving, and we don't have to worry about losing all our progress that we've made. So I'm going to go to File, Save Scene, go into our save scene, or into our scenes folder, and we'll just call this one Level 1. Nice and simple, and save that. Okay, so now we've got the basics of our project set up. Let's start doing some new things. So the first thing we're going to take a look at doing that's a little bit different to what we've done previously is using a sprite sheet in the game. So down here we have an image that has the various bricks we're going to use for our game. We've got a paddle down here, and then we've got a little ball down the bottom. Now at the moment, if we were to drop this into our scene, it'll just drop all three pieces in, which is obviously no use to us. We want to have it broken out into separate pieces. So one of the handy things in Unity is that when we have a sheet of sprites like this, we can chop it up into multiple bits and use those individual pieces as objects within the world. So as a demonstration, we're going to break or set up this sprite sheet into multiple pieces. So what we do is in the inspector here, when we have our brick paddle ball sprite sheet selected, if we go to sprite mode, we're going to set that to be multiple. We're going to go down here to filter mode, and instead of saying bilinear, we're going to set it to point, and that'll make sure we have sharp textures. If we set it to different filters, we can end up with blurry textures and stuff like that, which we don't want because these are 2D objects that we want drawn properly in the world. If we go down to max size here, we want to set this to be close to whatever the size of the sprite sheet is, and you can see if you look down here, the size of our sprite sheet is 128 by 128, so we want to use 128 here. You want to use the lowest number above what your sprite sheet is. So say if your sprite sheet was 129 by 129, you'd want to use 256. You always want to go the next lowest number above whatever the longest edge of your sprite sheet is, basically. But ours is 128, so we can use 128. For compression, we don't want to use any compression. We want it to be absolutely perfectly the way it is. And with all those set, we can hit apply. And then now that it's a multiple sprite sheet, we can go into the sprite editor here, and we can chop it up into different pieces. So we've got these three different pieces here, and there's multiple ways to chop up sprite sheets. You can do it automatically. You can do it by, say, if you have an evenly spaced, say you've got a sheet of character movements, you can chop it up into a grid of different objects, or you can do like this and just click and drag, and it'll create a box just like that around whatever area you draw, and that'll create the objects that we want to use. So this is going to be just one of our bricks, so it'll just be a brick. Right here we're going to draw around our little paddle, and we're going to call it paddle. And then finally down here we're going to draw this around our ball. Now you can see there I didn't quite draw around it properly at the top, so if I zoom in, what you can do is click and drag the box like this to make sure that you're fitting around to the edges of whatever object you have just perfectly. So you can readjust it after you've drawn the first box, which is a very handy and helpful thing. So we're going to obviously call this our ball. A small a. There we go. So we're going to apply the changes we just made like this, and then we're going to close out of this little window. Okay, so the next thing we're going to do is I'm just going to drag the ball into the scene here, and I'm going to drag the paddle in down here. Now at the moment we've got our paddle down here, and it's quite small, and our ball is quite small too. And that's because by default, when we import a sprite sheet, it sets the pixels per unit to be 100. And basically what that means, if we switch back to our scene view here, you see these little blocks in the background. Each one of those is 1 unit of the screen. So if you have an image with 100 pixels per unit, that means every 100 pixels of that image will show up as one of these blocks. So at the moment that's set a little bit too high for what we have here. We're going to adjust it and set it to be 64 pixels per unit, and if we hit apply now, we'll see our images in the center will get bigger. So I'm going to hit apply, and there we go, our images suddenly get bigger just like that. So you can adjust the pixels per unit relative to how you want to use them in your own game, but we want to set them up so by default they all go to be this size. And of course you can manually make your objects bigger within your game by growing and shrinking them in the hierarchy over here, or in the normal controls over here. But you ideally want to keep all your sprites on a consistent pattern. So that's why you'd want to know what value you're importing your sprites in with and try and be consistent and stick with that to keep everything in relative scale to each other. Okay, so we've got our ball and our paddle in our scene here. So let's drag in a brick as well. And now, of course, all these objects are going to need to be able to interact with other things within the world. So we've already set up the walls to be having box colliders. So let's do the same now for our bricks and our ball. So for the brick, we're going to give it a box collider 2D. For the paddle, we're also going to give it a box collider 2D. But for the ball, we're going to give it a circle collider, which is another one of the basic 2D components. Actually, I'll just delete this here. So so we can have a look. If we don't type in anything into the search bar, you can also navigate to any items by going through the list here. So we're looking at physics 2D objects. So we're going to go into physics 2D, and you can see there's a list of all the various different physics 2D pieces you can use within Unity. So what we want to select is the circle collider right there. And if we zoom in on our circle, you can see that we've now created a little green outline around our ball, which is representing the physical boundaries of that within the world. Okay, so we've got our various different pieces set up. One of the next things we want to do is make some changes to our bricks. So at the moment we've got just this one simple brick. What we want to do is add some interest into the game and make it more exciting. So we're going to do that by changing the color of this one first. I'm going to make it a nice blue brick like that. Then what I'm going to do is make this brick a prefab, because we're going to want to be making changes to how the brick operates and how the ball interacts with it, much like we did with the paddles in the previous game project. So we're going to go into our prefabs folder, drag the brick and drop it in there. And then what we're going to do is drag that back into the world here. We're going to make a few of these. So we're going to drag, say, 8 of them in like this. Like so. And then we want them to be relatively similarly positioned as well. So our original brick is at 2.7, so we'll adjust that to be 2.5 just to keep it nice and simple. So we're going to do the same with all the other bricks that got dragged in. So we're going to go 2.5 like that. And then our first brick is at minus 7 point whatever. So we're going to set it at minus 7.5, just minus 7. Yeah, just minus 7. And then say this one here, we're going to set this at minus 5. This one here, we'll set it at minus 3. This one here will be minus 1. This one will just be at 1. And so on. We do all of them, making them nice and evenly spaced so they don't look like they're just being randomly thrown in there, which they have been. So once they're all in position there like that, we're also then going to make them a little bit more, or with a little bit more variety by adding some color to them. So we'll make this one sort of a pinky purple. This one can be some light blue. This one will go for an orange. It's just to make them stand out a little bit more from each other, just to add some variety into the game. So I'll make this a bit more purple. This one can be green and yellow and red. There we go. So we've got a nice little selection of various different bricks in our game. And as before, they're all prefabs, so any changes we make to this original brick can be applied to all of them without changing the color that we've now customized for their individual instances. One other thing we'll do before we go any further, at the moment we've got a lot of bricks now starting to take up space in our hierarchy, and that's not really very useful for us. So what we're going to do is create a new object. We're going to go create empty, and we'll call this bricks, and then we're going to click and drag the original brick underneath it, and we'll do the same for the other copies and drag them on top of where it says bricks, like that, so they become a child of bricks, and now we can just hide that like that, and we don't have it taking up all the space that it was a second ago. We'll actually do the same with our walls here as well, because there's no reason for them to be taking up space. So we'll go to our walls like this and pop that in there. There you go, we have our bricks and our walls all sorted out. Perfect. Okay, so now we need to start adding some movement into our game. We've got our bricks set up, so let's start making some actual reactions happening. And now the first thing we're going to do is add some code to move our paddle along the bottom. Now we've already made a paddle controller script in our previous project, so what we're going to do is reuse some of that code in this project here. And it's important to remember that when you're working on multiple projects, if there's code that you can take over from one thing to another, it's very handy to be able to just reuse your same code over and over again, because it can cut down on a lot of programming time. Even if it's relatively simple stuff, it's just handy to have it done so you don't have to think about it anymore. So what I'm going to do is I have my scripts folder open from the previous project, and I'm just going to drag the paddle controller script into our current project like this, and it'll create a copy of it in our project. Now it's given us an error because there's no ball controller script yet, but we're not actually going to be using the ball controller script in the same way in this project. So I'm now going to open this up in MonoDevelop here, and we're going to make some changes to this that will allow us to use our paddle controller within our game here. Okay, so once the script is open within MonoDevelop, we're going to first of all start by taking out some unnecessary things. So because this is no longer a two-player game with two paddles, we don't have to worry about whether one of them is player one, so we'll get rid of that. Again, it's a one-player game, so the paddle will never be controlled by the AI, so we don't need that. And our ball controller reference was used for the AI to be tracking where the position of the ball was, so we'll just delete that and get rid of it. And then in our start function, this is no longer being used because we're no longer looking for the ball at all, so we'll delete that. And then down here, where we have if it is the AI do all this stuff, we'll just delete that bit of code like that. And we'll scroll down a little bit further to make sure we delete the curly bracket that was associated with that bit we just deleted. And then here, where we're checking if it's player one and then doing a certain kind of movement, or player two and doing a different kind, we're no longer doing that either. So we're going to delete all of this else statement like that. And then we're going to delete that curly bracket and this if statement up here. So now we're just down to our movement code here. So I'm going to select this and indent it, or unindent it, so that it's back in line where it should be, because we've now removed two sets of curly brackets that it was nested within previously. Okay, so now the thing is that our movement code is at the moment based all on moving our paddle up and down. But we don't want it moving up and down, we now want it to be moving left and right. So instead of using W and S for our keys, I'm now going to use D for moving to the right and A for moving to the left. The kind of standard kind of keyboard gaming controls for up and down and left and right are what we're using. But of course you can always use any other combination of keys, or you can use the arrows for the left arrow or the right arrow for moving in different directions. So if we're pressing D, so we're moving to the right, instead of our transform position wanting to add onto the, or wanting to add the speed onto the y-axis, and which moves it up, we want to instead add this speed by time.delta time. So we're going to cut that out like that. We want to add that on to our x-axis, very simply like that. And we want to do the same for when we press the A button to move to the left. We want to minus the speed from the x-axis and not from the y-axis. Okay, so that gets our little bit of movement here, and also that sets up our direction inputs like we had before. The next thing we want to do is now our new limits should be on the left and on the right instead of being at the top and the bottom. So here we're checking, instead of checking that the transform position.y is greater than the upper limit, instead we're going to check that the transform position.x is greater than the right limit. Oh, I didn't rename this, of course. We need to rename our upper limits and our lower limits to be the left and right. So our lower limit will be the left, and our upper limit now will be the right limit. Because it makes more sense to use left and right. It doesn't make a lot of sense to use upper and lower when we're talking about moving side to side. So we'll go back down here, and now, as I said, we have our transform position.x. If that's greater than our right limit, then we need to set our upper limit.position.x on the x-axis, and then our transform.position.y on the y-axis. Actually, sorry, that shouldn't be upper limit, that should be right limit, of course. So it'll be right limit. So now we're setting it, if we go past the right limit, then we need to make sure our paddle is constrained to be at the right limit. Otherwise, we need to check if our position.x is less than our left limit.position.x, and I just realized we never changed the right limit position. We should be checking if we're at the right limit.position.x. So on our, now we're doing our left limit position.x, and we need to do the same here where we switch these around. So we'll take out our transform limit, change this to be x. I'm going to paste that transform limit back in there and change that to be y. So now our paddle will only be able to move to whatever limiting amounts we set on the left and right of the x-axis. Okay, perfect. So there's one other thing we need to do, and that is down here. We need to adjust what happens when our object stops hitting the paddle and starts changing its direction. Instead of manipulating its movement on the y-axis, we're going to manipulate its movement on the x-axis. And unlike the previous game where we wanted things to speed up and make it more difficult for players to hit the ball back and forward, we don't want to do that at all anymore. So I'm just going to delete that and paste back in the direction adjustment, and we're not going to multiply the velocity on our y-axis by any value because we want it to remain constant as it goes. So I'm going to save that, and then that should be it for our little bit of adjustment to our paddle controller. So we're going to pop back into the game. Now of course we're going to need to create our left limit and our right limit. We'll just wait for this to finish compiling, and then that error should disappear. There we go. So we're going to create our left limit first. We'll call it the left limit, and I'm going to click and drag it, and much like we did last time, I'm going to set 0 on the y-axis, and we're going to move our paddle over to the left as far as we can and say that is at minus 7.59. So our left limit we'll set at minus 7.59. Then we can duplicate that, call this the right limit, and move this to plus 7.59. So if we go back to our paddle now, we're going to add the paddle controller script to it by just clicking and dragging just like that. We're going to associate these left and right limits into the right places like that. We'll set our adjust speeds as we did before, and we'll put the normal controller speed back to be 10 as well to keep it nice and simple and nice and straightforward. And now if we go and hit the play button like this, we should end up with this allowing us to go all the way to the right there like that, and then all the way back over to the left. So perfect, we've now got our paddle controller set up, and it's a lot more straightforward and a lot more simple than we had to do last time. All it required was adjusting a bit of the code that we used in our first game. Okay, so now that we have our paddle moving, let's get our ball moving at the same kind of time. So we'll go to our ball here. We've already given it a circle collider, which is perfectly fine, but now we need to give it a rigid body so that we can apply physics to it like we did previously. So we're going to go physics 2D and add a rigid body 2D. just like that. We're again going to set our gravity scale to be 0 because we don't want this ball just magically falling down by itself. We want it to bounce off our paddle and bounce around between all the various bricks in the world. And the next thing we want to do is go ahead and create a new script that will control our ball. Now we're not going to reuse the same script we did last time because we're going to do some different things with our ball controller script this time, but we are going to create this script and call it again ball controller. While that's compiling there for a second, we also need to remember that we need to apply the bouncy material that we made last time in our previous project. So we're just going to go ahead and make that again. So we're going to our materials folder, we're going to right click and create a new physics material 2D. Again, we'll call it bouncy, and again we'll set the friction to be 0 and the bounciness to be 1. So perfect. And now we'll go back in here and we're going to open up our ball controller script. And we're going to set a current, or a couple of simple little variables that we're going to use to control our ball. So what we're going to want to have, we want to make sure, because our ball will be bouncing around from side to side a lot more whenever it hits against bricks and stuff like that, we don't want our ball to be able to go too fast. So it could happen that our ball would start jumping around like crazy. We don't really want that. So we want to limit the amount of speed that the ball can have. So we're going to use a public float that we're going to call max horizontal speed, like that. And then we're going to use that to limit how much our ball is moving within the world. But of course, for our ball to start moving at the start of the game, we also want to be able to give it a certain amount of speed to start off with. And that'll be another value that we're going to use called public float that we're going to call vert speed. So that'll be how fast the ball will start moving in a vertical direction. And much like we use in our previous project, we need to be able to apply this speed to our ball to start off the game. Because when we start, we need some actual action to happen, not just for it to kind of float around there doing nothing. So we're going to need to access the rigid body that's attached to the ball. So we're going to create a new private rigid body, much like we did in the previous project, rigid body 2D, and instead of calling my rigid body, we'll just call it the RB, nice and short, for the rigid body. And then at the start, as soon as the game starts, we're going to say, okay, the RB should be equal to get the component that is attached to the same object that this script is attached to, and the component we're looking for is the rigid body 2D component. So that'll find the correct component that's attached to the rigid body, and it'll make sure it's applied to this variable. And then the next thing we want to do is, as soon as the game starts, we want to say, okay, set the velocity of this ball, so the rigid body dot velocity is equal to a new vector 2 that will say it'll start out moving at vertical speed, and it'll start out moving at whatever we set to be the max horizontal speed. So we're going to save this, and we're going to pop back into the game just to see this in action, and then we're going to make sure that we set that in our game. And so, as I said, the reason we don't want to let it go above a certain amount of speed is, say if our ball was coming down at this angle and it hit our paddle, and our paddle then was moving to the right, then we start making the angle shallower and shallower. At some point we could end up with the ball kind of moving almost horizontally, just kind of bouncing back and forward, and that's not going to make our game very fun. So that's why we want to make sure that our horizontal movement is constrained to be a certain amount, that we can't affect it too much. So now that that's finished compiling, we're going to go to our ball, and then we're going to add the ball controller script to it. So I'm going to start typing ball, there we go. And we're going to need to decide how much speed we're going to give to it. So we're going to keep it nice and simple and just kind of use let's say we'll say just 5 for both values, nice and simple. And we're going to hit play, and we'll see the ball go up. There we go. I haven't given it the bouncy material, I just realized, so that's why it's not really being very helpful. It's just kind of flapping around a little bit. So let's change that and give it the correct material in its circle collider. And we'll start going again. And now we should get, there we go, the ball bounces off just the way we want it to. And now we're able to bounce it around like this. So as you can see, now I'm starting to make it move from right to left a lot more, and it's getting a lot faster, and it's making it a lot harder to control, and which will just end up being really unfair on the players. It gets out of control and you can't really do anything with it. So as I said, we want to constrain the speed of the ball as it moves from side to side. So what we're going to do is just add a couple of simple if statements into our update loop here. So we're going to say if the rigid body velocity on the x-axis is greater than our maximum horizontal speed, then we want to set it so that the rigid body velocity is equal to a new vector 2 which has max horizontal speed as its x-axis, because we don't want it to go any faster than the max horizontal speed, and on the y-axis we're going to leave it alone at whatever speed it's currently going at. So the rigid body dot velocity dot y. Oh, and hit our semicolon at the end. And then after that we want to say else if, again, the rigid body dot velocity dot x, if this time if it is less than minus max horizontal speed. So we have it currently set that max horizontal speed is 5. If it is less than minus 5, so that's when it's moving to the left. Well, if that is true, then what we want to do is do the same bit of code we just typed here. If I could highlight it properly, paste it back in there, and instead set the vector speed to be minus max horizontal speed. So we can save this, and what we can do, much like we did previously, is to make sure that our debug.log is telling us what the current speed of the velocity is. So we used debug.log before for when our ball stopped colliding with the paddle, but we're just going to have it running constantly when this script at the moment. So we're going to say debug.log the rigid body dot velocity. I'll save that, and then we should see when we go back into the game, we should be able to keep track of what the velocity is doing at any particular time. So it's finished compiling, we can play and keep an eye on the numbers at the bottom. You can see we're never going above, so I've slowed the ball down there. Oh well, I just lost the ball completely then, but you can see I was able to slow the ball down and we saw the change in the velocity. I could then speed it back up if I wanted to by manipulating the direction. There we go. See, I've slowed it down more. I slowed down even more by making it go the opposite way. And as you can see, we're slowing it down like that. So let's speed it back up again and slow it down. You can see we're making changes to the velocity of the ball, and that's exactly what we wanted to be doing. But if we speed it up, no, I managed to miss that one. We can't speed it. I missed it again. But we can't speed it above the maximum horizontal speed that we have set, which is perfect. That's exactly what we wanted to do. We don't want the ball to get too out of control. Now, you don't necessarily want the maximum horizontal speed to be the exact same as the vertical speed. So say, for example, what we could do is just set it, as soon as the ball starts, it actually uses the vertical speed on the x-axis as well, like that. So we have our ball traveling at a constant speed once it's first started, but back in the game here, that means we're still able to have it go faster once the game is being played. So say if I set this to be, say, 8. So now if we go into the game, once things start moving, our ball goes like that. And at the moment it's going to 5, but if I can speed it up, there we go, it's starting to go 7 there. So our game now is a little bit faster to play, but it's not unreasonable, it's not unmanageable. And again, it's about finding the balance between these things. And that's only going to come with your own testing and feeling the game out for yourself and feeling how it feels. So, but we've successfully now controlled the speed of the ball, and that's what we really wanted to do. Okay, so now that we have our ball and our paddle set up, the next thing we want to do is make it so that we can actually control when we start playing the game. So what we're going to do, I'm just going to first of all reset our paddle so it's kind of roughly in the center, and we're going to move our ball into roughly a starting position like that. And what we want to do is give our players the ability to start the game. So for example, what we're going to do is set it so that when the player hits the space bar, it launches the ball and starts it moving. So to do that, obviously then in our ball controller script, we don't want it to automatically start firing the ball. What we want to do is hit / just like that. And what we're going to do is create a new variable here that will control whether the ball is currently activated within the game. So we're going to create a new public bool called ball active, and what we'll do is set this to activate, and that'll be what we use to start the ball moving in the game. So what we're also going to need to do is set it so that our ball, when it's not active, stays above the paddle. So say for example, what we're wanting to do is if our player starts the game, they might want to start the ball firing at any of these particular bricks in the world. So what we can do is then create a new position that is slightly above the paddle, and that's where the ball will move to whenever the game is not currently active and that we're waiting for the player to fire off the ball. So what we'll do is we have our ball active bool, and we can check and say if our ball active is not true, and the way we check if something is not true is we put an exclamation mark in front of it. So we're saying if ball active is false, which is our bool value up here, and when you create a bool value, by default it's set to be false, so in our inspector it'll start off as false. So if our ball active is false, then our velocity of a rigid body shouldn't be doing anything, so we'll say our rigid body dot velocity is equal to vector 2 dot 0. So that makes sure that our ball won't go flying off and bouncing around all over the place when our player hasn't started the game yet. And then we want to set the position of the object, so our transform dot position. We're going to want to set that to a particular point in space. So what we're going to need to do is create a reference to a transform position, which will be a public transform that we'll call our start point. And what we're going to say is if the game isn't currently active and our ball is just kind of sitting there doing nothing, it should be set to this point, which will be kind of just above our paddle. So we're going to say start point dot position. So our transform position is equal to start point dot position. So I'm just going to save this and we'll go back into the game, and we'll set that up now so that it's in place within our game. So we just wait for it to compile for a second, and then what we're going to do is go to our paddle here. We're going to create a child object, so we're going to create empty while the paddle is selected, and we're going to call this the ball start point. And if we go back to our ball, we're going to scroll down and we have the slot here for the start point, and we're going to click and drag that into there. So now we should be able to see when we hit play here, our ball won't start moving around. Oh, we've lost the ball. Where is it gone? It's at -4. Oh, it's gone inside the paddle. That's why. Did I click and drag the... Oh, I never moved the start point up. That was our problem. Of course. We actually need to drag the start point up above the paddle. There we go. For some reason I just imagined that I had done that. So if we hit play this time, now we have the ball is just above the paddle where it should be, but if we move the paddle to the left and right, now the ball is kind of just above it, so we can use it to control where we're going to start our game from. Okay, so if we've got that set up, then we need a way of activating the ball back into the game. And to do that, we're going to use a game manager script, much like we used in the previous project, but our game manager needs to be able to call something on our ball controller to be able to activate the game. So at the bottom down here, we're going to create a new script that we're going to call public void activate ball. I don't know why every time I type ball I type a capital A. I don't know why that is, but anyway, so we're saying our activate ball little function down here will basically check, or it'll basically set our ball active to now be true. So that means our ball is not going to be held in place at the transform position, and it's not going to have the velocity set to be 0. So we can make sure that that's true now, and also we can start it moving by saying the rigid body dot velocity is equal to, just as we did up here, we're going to take the new vector2 and set it to be the vertical speed and start moving at the vertical speed. So perfect, that's exactly what we wanted to do, and we can just save that. But of course at the moment we have no way of calling that. So what we need to do is go ahead and create the game manager script that we just talked about. So we're going to create a new C# script that we're going to call the game manager, and we'll open that up in MonoDevelop. And basically all we're going to have at the moment in our game manager is just an if statement that checks if our player has pressed the spacebar. So we're going to say if input.getKeyDown, and the key code that we're looking for is the space button. So keycode.space. So if the player presses the key code for space, then what we're going to do is on the ball controller script, we're going to call the activate ball function. So if we're going to be doing some stuff with our ball controller, we know there's only one ball controller in the game, so we can do like we did in the previous project again, and we can have a reference here to the ball controller that we will call the ball, and then in our start function we can say, okay, the ball is equal to find object of type ball controller. So find the ball controller within the scene and apply it to our current the ball variable here. So then when we press the space button down, what we can say is, okay, on the ball object we want to run the function activate ball. So we can save that and we can pop back into the game. And of course now we need to create an object for the game manager to be attached to within our world. So we'll wait for that to compile for a second. Then we'll go over here and create a new empty game object, and we'll call this game manager. Oh, manager, didn't spell that very well. Game manager, and we're going to apply that script to it like that. And of course it has the slot for the ball here. I should actually, as I look at that, I should set that to be a private variable, because we're not going to be worrying about setting that at all. It's going to be automatically set. So we'll just save that and go back in here, and there we go, it disappears from our game manager. And now if we hit play, what we can do, we can move back and forth with the ball, and now if we hit space, it'll start the game running. Of course at the moment also if we hit space, it makes the ball apply that movement force because we're calling the activate script. So we're going to disable that as we go a little bit further in it. But for the moment, that's all we needed to do. So our game manager now controls launching our ball. Actually, now that I think about it, let's just quickly fix that while we can. So we're going to add an extra bool variable into our game manager. We're going to create a public bool, and we're going to call it game active. And basically by default our game will not be active, and so what we're going to add in here is another element to this key code space check. After we have the closing bracket for the key code space, we're going to add in here, we're going to say, we're going to put 2 ampersands in, and that means and, basically. So what we're saying is when you're doing any kind of check within Unity, these little 2 symbols like this means and. So what we're saying is if the key code space is pressed and our game active is not true. So if game active is not true and we press down the space bar, then it'll call the activate ball script and it'll set game active equals true. So that means it'll only activate this little function once, and then we won't be able to repress it over and over again until we set up a system that will, when the ball goes down into this area down here, we'll set it so that our game manager then becomes our game active becomes false, and then we're able to press the button again one more time. So we'll see here now when we press play. So at the moment our game active is set to be false, and at any point we can hit the space bar, and now our game is playing away like that. But now if I hit the space bar, absolutely nothing happens because our game active is true, so therefore we can't make any changes to it. So perfect, that's exactly what we want to do, and now we can move on to our next stage of developing this game. So now that our ball and our paddle are a little bit more controllable, let's start adding the ability to destroy the bricks up here at the top of the screen. So to destroy the bricks, we want to make sure that we know what it is we're bumping into that is a brick. So much like we used again earlier before in the previous project, we're going to use tags to define which of these things are bricks. So we know that the walls won't be bricks, so we just need to make sure that all these brick objects get a unique tag. So we're going to go down to add tag, we're going to add the brick tag to them, or we're adding the brick tag to the list there. Then we go back into our bricks drop down, and we need to make sure that we drop that down and then select each of these individual bricks. I'm not sure why some of these have a child game object, but that's okay. I'm just going to add the brick tag to them. I'm unsure why that has a transform as a child of it. It's a little bit strange. I'm just going to delete those like that. So we added a tag to each one of those individually. We could have also equally just have gone to the original first brick and hit the apply button to apply that brick tag to all of them, and you'll see that actually on the on the other bricks it's still highlighted in bold that we've made a change to these ones, because we made an individual change to them, although the change we've made has actually been applied to all of them. So we've got our bricks all set up, so now we know a way of distinguishing those bricks from everything else. So now we can make an addition to the ball controller script that will go, okay, I've hit a brick, so maybe destroy that brick. So we'll go back into our scripts and into our ball controller script, and above where we have activate ball, I'm going to add the function in here for void on collision. Enter, I think, should work. No, actually we'll use on collision exit, so when our ball is bouncing off the object, that's when we'll destroy it, not when we first come into contact with it. So on collision exit 2D, we'll look at collision 2D other, just like we did before. And basically all we're going to do check now is if the other game object has the tag which is equal to brick. So again, we want to make sure that we spell it the exact same and capitalize it the exact same as we've done in the game here. So if the other game object has the tag brick, then quite simply all we want to do is destroy other dot game object. So that'll just destroy the brick and make it disappear from the game. And the reason we don't do that when we're entering the collision is because if we did it on collision enter, what would happen is as soon as the ball touches it, it would make the object disappear, but then the ball would just keep going through any bricks it hits, and that's not what we want to happen. We want our ball to bounce when it hits a brick and then the brick be destroyed. So let's go into our game and actually test this out in action. So we'll let that compile down there, and as soon as that's done, there we go, we can hit play. And now we should see, there we go, when our ball hits a brick, it bounces off and the brick is destroyed. And you can see it's been removed from the hierarchy over here, which is perfect. Okay, so there we go. That's how we can destroy our bricks. Now obviously we'll add some more functionality like points and stuff like that as we go, but we're adding one thing at a time, and the next thing we need to add is to make sure that when our ball bounces against our bricks and comes flying back down, if we miss the ball, that our player can get back into playing the game. So now we want to make sure that when our ball goes off the bottom of the screen, our players can go back to playing the game. So the first thing we're going to do is create an area, much like we did for the goals in the previous project, so that when the player's ball enters these zones, we know that we can call what's going on. So we're going to first of all create a new empty object that we will call we'll call it the respawn zone. We're going to add a box collider to it, box collider 2D. We're going to make sure that it's a trigger so that our ball doesn't just bounce off it when it hits the bottom. And then we're going to drag it down here, and I'm going to scale it up on the x-axis so it covers all of the bottom just like that. And so when our ball enters this zone now, we want it to do something. But to know whether it's entered this zone and not some other zone, we want to make sure that we give this a unique tag. And the tag we're going to give it is respawn. It's one of the default ones already built into Unity, so it's very handy. So we're going to click on that and just add it there so we don't have to create it ourselves. And now we're going to check how to add this, or not how to add this, but how to make this work within our scripts. So we know that if we were to go to our ball, for example, and now if we entered this zone, we could say our ball active is no longer true, so we get reset back to be just above our paddle. But we'd also need to reset on our game manager the game active bool to go back to being false. So let's look at doing that in our scripts. So on our ball controller, down here, just below our on collision exit, we can add a new void on trigger enter 2D, just like we did before, and say collider 2D other, so whatever the other collider is that we just entered the trigger for. What we'll do is check if the other dot tag is equal to respawn. Again, we need to make sure it's spelled correctly. And if that other tag is respawn is correct, then what we'll do is we'll need to set our ball active back to being false, so that our rigid body's velocity will be set to 0 and our position will be set back to the start point. So here we can say, okay, ball active equals false, like that. And the next thing we need to do is on our game manager, we need to set this bool back to being false. So what we could do is create a reference to the game manager. Well, we will create a reference to the game manager, but what we could then do is just directly set this bool to be false, and that would be perfectly fine. But we'll want to, as we go further in the game, add more functionality to this. Like, we want to have lives that our player can lose, and then when we have lives, we'll want our game manager to be counting down those lives as we go. So what we're going to do is create a function that we'll call public void respawn. Actually, we'll call it respawn ball, and we'll put our little brackets in. And within this function, this is what we're going to use to set our game active equals false. Because like I said, later on, we'll also, within this function, have this will take away a life from the player, and it'll do some other little bits and pieces as we go further in the game too. So now that we have a life being taken away, or sorry, now we have our respawn being set, so our game active is now set back to being false. On our ball controller, we'll need a reference to our game manager. So back up the top here, we'll create a private game manager called the GM. And the reason we're making this private is we know there'll only be one game manager in our scene. There's no point in having multiple game managers. So we can do the same thing we've done before in our start function of saying, okay, the game manager is equal to find the object that has the type game manager. So that means it'll find the right object within our world because there's only one of them. And then down here, back in our on trigger enter, we can say, okay, on the game manager, call the function respawn ball. And we put our two brackets and hit our semicolon like that. Okay, so we'll save this and we'll jump back into our game now. And we should be able to see as soon as the ball goes down below the little zone down here, our little respawn zone, as soon as it goes down below that zone, it'll get pushed back into its position, and then we can hit the spacebar again and get back to playing our game. So there you go, you see it? Gets reset, it drops down, and it keeps getting reset back into position just the way we want it to. So say for example, we'd probably want this to last maybe 3 lives or something like that, and then we would get it when next time it hits the zone down there, we'll lose all those lives. So now that we've got our ball being reset back into position that we want to, let's actually take a look at managing those lives for our player.